Nothing in life is to be feared. It is only to be understood. Everything is theoretically impossible until it's done. Science is inventing, experimenting, growing, taking risks, breaking rules, making mistakes, and having fun. It is the way of helping our brains to grow in finding new knowledge and helping us all to defeat our curiosity of how this world develops and works today. Science is important because it has helped to form the world in which we all live today. Science basically means constantly walking on a tightrope between blind faith and curiosity, between expertise and creativity, between bias and openness, between ambition and passion, between arrogance and conviction. In short, between an old today and a new tomorrow. So, I, Garima Sharma, a student of grade 9, wholeheartedly extend my heartfelt greetings to all. Science walks on 2 feet, namely theory and experiments. But continuous progress is only made by the use of both. So, we all believe that all experiments are living experiences, even if they do not work as planned. So, we therefore present before you some experiments based on law of conservation of energy. But before that, let us understand what energy is. Energy in physics is simply the ability to do work. It exists in different forms such as potential energy, kinetic energy, thermal energy, electrical energy, chemical energy, nuclear energy, and there are many other various forms of energy. Now, what is law of conservation of energy? Law of conservation of energy is simply the principle of physics according to which the energy of interacting particles or body in a closed system remains constant. That is, energy can neither be created nor be destroyed. It can only be transformed from one form to another. The total energy before and after transformation remains same. Experiments are mediator between nature and ideas. So, here are the students of St. Joseph's Convent Secondary School, Pathankot, with their experiments to prove law of conservation of energy. But before we move on to experiments, I would like to thank our principal, Reverend Sister Frida, for giving us this wonderful opportunity to enrich our minds and ideas. I would also thank our physics teacher, Mrs. Priyanka, for her able guidance and kind support throughout the completion of our experiments and this project. Understanding this approach, I present before you the enthusiastic Josephites who will show their zeal and passion towards this subject through their experiments. So, without any further ado, let's get started.
Hi everyone, I am Aryan Sharma of class 9A, roll number 7, and today I am here to present a short video on the topic Law of Conservation of Energy. Now, what is energy? Energy is the capability of any body to do work. If a body does work, it is said to possess energy. Its unit is joule and it was given by James Prescott Joule. Now, one thing we need to understand before moving on to law of conservation of energy is that energy can be transformed from one form to another. There are many types of energies. Example, electrical energy, mechanical energy, which includes kinetic energy, potential energy, heat energy, thermal energy, and so on. Now, electrical energy can be converted to mechanical energy by using a simple motor and vice versa. Now, let us move to law of conservation of energy. Law of conservation of energy states that energy can neither be created nor be destroyed but can only be transformed from one form to another. This means that the total energy of the system remains constant. Now, let us take an example to understand it better. This is my apparatus of the example which I have chosen. On the leftmost side, you can see a block to which a spring is fastened. Also, you can see a starting line and a finishing line before all the wooden blocks kept, between which a tape is also kept. Now, here on the right side, you can see all the wooden blocks. To the right, there is one starting line and a tape. Okay, so now you have seen the apparatus of the example which we have chosen. Now, let us see the mathematical explanation of it. So here, this is the spring, this is the tape, and these are the wooden logs. Here you can see X, which is the length of the compression of the spring. These both are the starting and finishing line of the tape, and the distance is Y. These are the wooden logs. This is the second tape, and the same distance is chosen as this one, which is Y. Now, we have to prove the law of conservation of energy. In it, when we compress the spring, the elastic potential energy in the spring is equal to half kx square. K is the constant of proportionality here, and x is the length of compression. Also, negative of force is equal to kx. Rearranging this is k is equal to negative of force divided by x. From these two equations, we will equate that elastic potential energy would be equal to half into negative of force by x into x squared, which will give us the elastic potential energy as negative of force x by 2. Now, we need to find the kinetic energy of the moving tape, and then we will say that the law of conservation of energy is valid here. But we have a problem. We don't have a device to calculate the velocity of the body. So, what to do? Now, here we will take the example of work energy theorem, which states that delta of kinetic energy is equal to the work done. The elastic potential energy of the spring will convert it to the kinetic energy of the moving tape, which is equal to the work done. Therefore, the elastic potential energy would be equal to the work done by the tape. Equating the elastic potential energy and the formula of work done, we get that negative of x by 2 is equal to y. This means that negative of x is equal to 2y. This means that if x is equal to negative 8 units, we will get y as 4 units. Now, it has been a long journey. We have derived the equation. Now, we just need to prove the law of conservation of energy. Assuming the force as constant, if the work done by this tape is equal to the work done by the second tape, which means that the distance here, which is equal to y, is equal to the distance here, then these both tape will have the same energy. If they have the same energy, this means that the both have done the same work. This means that the total elastic potential energy of the spring is converted to the first tape The first tape gets over the distance of y, hits these logs of wood. They further transfer the energy to the tape, and it also moves the distance which is equal to the first tape. If they move the same distance as the first tape, this would prove that the law of conservation of energy is valid here, and in the system the total energy remains conserved. Thank you. Now, let us see experimentally whether it is true or not. Now, hence you can see the tape has traveled the distance till the wall. Hence, it is proof that law of conservation of energy is valid.
Greetings to everyone. I am Anya Mahajan from class 9th B, and today I am here to explain the law of conservation of energy. So before we begin, let's start by asking a very simple question. What is energy? Energy of an object is defined as the capacity to do work and the quantity of work it can do. The SI unit of energy is joules. This unit was given by a renowned scientist, James Prescott Joule. We know that energy can be transformed from one form to another. For example, during combustion, the energy of fuel, that is the chemical energy, is transformed into heat energy. But in no case there is destruction in any form of energy or it appears on its own. Wherever measurement is possible, we have been able to prove that the loss of energy in one system leads to the gain in another system. This is known as the law of conservation of energy. The conclusion of the law of conservation of energy can be stated as follows. Energy can neither be created nor be destroyed. It can only be transformed from one form to another. Thus, the total energy in the universe always remains constant. This law holds true for all kinds of energy transformations. This law was stated by Robert Mayer in 1842 and was further firmly established by Helmholtz. I will explain the derivation of the law of conservation of energy. Here is the diagram. Let us consider a body of mass m placed at A. H is equal to AB, that is the height of the body. S is equal to distance of any point C from A. Small g is equal to acceleration due to gravity. V1 is equal to the velocity of body C. V is equal to the velocity of body at B. The velocity at point A is 0, that is u is equal to 0. This is because the object is at rest. Now let us move on to case A. Potential energy would be mgh. The kinetic energy would be 0 as the object is at rest. So, the total mechanical energy would be mgh plus 0, that is mgh. We know that the total mechanical energy is the sum of kinetic energy and potential energy. So, we mark this as equation 1. Moving on to when the object is at point C, we find that first we have to find the value of v square in order to put it in the formula of kinetic energy. So first we use the third equation of motion to find its value. We get v1 square is equal to 2gs. The kinetic energy is equal to half mv square. We put the value of v square in the formula and we receive mgs. The potential energy is equal to mgh minus s. This is because the distance between C and ground is h minus s. Now, the total mechanical energy would be mgh minus mgs plus mgs. The minus mgs and plus mgs gets cancelled and we receive the total mechanical energy as mgh. Now, for the last case at point B, we find that we again have to use the third equation of motion in order to find the value of v square. V square is equal to 2gh and h was the distance between the initial position of the object and the ground. So,
Now we put this value in the kinetic energy's formula, that is half mv square. We receive the kinetic energy is mgh. The potential energy for this case would be 0 as the height is equal to 0 as the object is on the ground. Therefore, the mechanical energy of the object is equal to mgh. From equations 1, 2 and 3, we find that the total mechanical energy of the body during free fall always remain conserved. So this was the derivation and proof of the law of conservation of energy.
Hope you liked the video. Thank you for watching.
Good morning, I am Mahira Adlakha and today I am going to perform a very simple activity based upon the law of conservation of energy. We've learned earlier that the law of conservation of energy, which states that energy can neither be created nor be destroyed. It can only be converted from one form to another. So in this experiment, we'll show that how energy gets converted from one form to another and how that body uses the energy to bring an impact. So let us start with the activity. For this activity, you will need a transparent plastic jar with a powdery substance. I have taken suji, you can take any other powdery substance like sand, etc., and a pencil with 8 yellow rings for the mark. It's just to mark the pencil. So let us start with the experiment. What we are going to do in this experiment is that we are going to drop the pencil from a certain amount of height and then see how potential energy gets converted into kinetic energy and what impact does the kinetic energy do on the surface of suji. And in the first case, we are dropping the pencil from a smaller height to have a smaller potential energy. As we know that potential energy is mgh, so height is directly proportional to potential energy. Smaller the height, lesser the potential energy. And if the potential energy is less, the kinetic energy when dropped will also be less. Hence, the total energy of the object remains the same. Let us see what happens in this case. In this case, we can see that all the rings are outside the heap of suji. That means only the tip of the suji is inside the heap and hence creating a smaller impact. See what happens when we drop the pencil from a greater height and increase its potential energy, and when it will be dropped, the kinetic energy will also be increased. As we know that total energy remains the same. The energy only gets converted from one form to the other. So now we can see that 2 rings have gone inside the heap of suji. That means it has made a deeper hole than the last case. Let us increase the height even more and then see what happens. As we increase the height, the potential energy increases, and when we'll drop the pencil, the kinetic energy will also be more as the total energy remains the same. And let us see what impact does it create on the heap of suji. So now we can see in this case that 4 rings are inside the heap of suji. 4 rings are inside the heap of suji. That means the hole is even deeper than the last case. Now let us compare all the 3 cases. The first case where the impact was least, and now the second case where the impact was more than the first one, and the third case where the impact was the maximum. So, in this simple experiment, we clearly saw that how potential energy got converted into kinetic energy, and we also saw that impact made by kinetic energy on the heap of suji. So, I hope you enjoyed watching this experiment. And
Conservation of energy. Greetings to all. I am Garima Sharma of 9th B, and I present before you a seminar based on law of conservation of energy. First and foremost, what is energy? Energy in physics is simply the ability to do work. It exists in different forms like potential, kinetic, thermal, electrical, chemical, nuclear, and various other types of energy. Now, what is law of conservation of energy? Law of conservation of energy is the principle of physics according to which the energy of interacting bodies or particles remain constant. That is, energy can neither be created nor be destroyed. It can only be transformed from one form to another. Let us understand this law more clearly through some examples. Water can produce electricity. Water falls from sky, converting potential energy to kinetic energy. This energy is then used to rotate the turbine of generator to produce electricity. In this process, the potential energy of water in dam can be turned to kinetic energy, which can then become the electrical energy. When playing the pool, the cue ball is shot at 8 stationary balls. The cue ball has energy. When the cue ball hits the 8 balls, the energy transfers from cue ball to 8 balls, sending the 8 balls into motion. The cue ball loses energy because the energy it had has been transferred to 8 balls. So, the cue ball slows down. In both of these examples, the energy has been transferred, neither created nor destroyed. I hope that you all understood the concept of law of conservation of energy.
Hello everyone, my name is Bhumi and I am a student of Standard 9th. Today, we are going to talk about law of conservation of energy. Before going to understand this concept, let us understand that what is energy. Energy is the ability to do some work. There are many kinds of energy: heat energy, mechanical energy, thermal energy, kinetic energy, potential energy, and many more. Law of conservation of energy states that energy can neither be created nor be destroyed. The total energy in a system always remains constant. To make it more clear, let us perform one activity. Here I have taken two bottles, bottle 1 and bottle 2. When I will try to push bottle 1, bottle 2 will itself move from its position. So let us check. So, from this we can conclude that energy transforms from one part to the other. So this makes our concept clear. Thank you. I hope you like my video.
Hello everyone, my name is Sana Daniel and I'm a student of Standard 9th. Today, we are going to talk about Law of Conservation of Energy. To understand this concept, first we have to understand what is energy. Energy is the ability to do work. There are many types of energy, such as heat energy, potential energy, kinetic energy, electric energy, etc. Energy converts from one form to another. For example, in winters, we rub our hands together to make them feel warmer. But what is happening when we do that? The kinetic energy of your moving hands is being converted into heat energy due to friction between the hands. Another property of energy is that it can neither be created nor destroyed. The total energy in a system always remains constant. And this is what we are talking about. This important property of energy is called Law of Conservation of Energy. Let's understand this property with the help of an example. Water can produce electricity. Water falls from the sky, converting potential energy to kinetic energy. This energy is then used to rotate the turbine of a generator to produce electricity. In this process, the potential energy of water in a dam can be turned into kinetic energy, which can then become electric energy. We saw that energy is neither created nor destroyed. It is just converted from one form to another. Let's summarize what we have learned. Energy is defined as the ability to do work. There are many types of energy such as potential energy, kinetic energy, etc. Law of conservation of energy states three important points. Energy can neither be created nor be destroyed. Energy changes forms. Energy in a system remains constant. Thank you for watching, and I hope you understood the concept of law of conservation of energy.
Greetings of the day to all. Today, I, Stuti of Standard 9th is going to give a seminar on the topic Law of Conservation of Energy. To begin with, we should know the meaning of energy. Energy is the capacity for doing work. There are various forms of energy such as heat energy, light energy, chemical energy, electrical energy and mechanical energy, which is the sum of potential and kinetic energy. Now the question arises, what is the law of conservation of energy? According to this law, energy can neither be created nor destroyed. It can only be transformed from one form to another. The total energy before and after the transformation remains the same. Let us understand this law with the help of an illustration.
Here is a simple pendulum. Let B be its mean position. Now allow the pendulum to oscillate. When the pendulum moves to position C, it gains height. Thus, at position C, it has maximum potential energy. When it is at position C, it is stationary for a fraction of a second and hence possesses zero kinetic energy. When the pendulum moves towards position B, its velocity increases. Due to increase in velocity, its kinetic energy also increases. That is, potential energy gets converted to kinetic energy. At position B, it has maximum kinetic energy and zero potential energy, as it is at its lowest position. When the pendulum swings from B to A, it again gains height, and hence its potential energy increases. However, due to gain in height, its velocity decreases, and hence the kinetic energy. At point A, it has maximum potential energy and zero kinetic energy. That is, potential energy changes to kinetic energy and vice versa. Thus, the energy is conserved.
I hope you understood the concept of law of conservation of energy. Thank you.
Greetings to all. Today, I, Sohani Jamwal of class 9th, is going to explain the principle of law of conservation of energy through an example. But before that, let us understand what energy is. Energy is the ability of a body to do work. Energy is of different types, such as heat energy, potential energy, kinetic energy, electrical energy, etc. Now, let us understand what law of conservation of energy is. One of the most useful properties of energy is that it can be changed from one form to another. For example, the chemical energy in wood changes to heat energy when the wood is burned. But though energy can change forms, the total energy in a system is always conserved. The amount of energy before a change equals to the amount of energy after a change. This principle is called the law of conservation of energy. We can also use a simple pendulum to observe the conservation of energy. A pendulum has two types of energy: potential energy, which is the stored energy, and kinetic energy, which is the energy of motion. Together, these make up the mechanical energy of the pendulum system. As the pendulum swings, its potential energy changes to kinetic energy, then back to potential energy, then back to kinetic energy, and so forth. Now, let's take the example of a tire swing. As you can see, at its starting point, all of swing's mechanical energy is potential energy. It has no kinetic energy because it's not in motion. As the swing moves downwards, some of its potential energy changes into kinetic energy. At its bottommost point, the swing's kinetic energy is at its maximum because it is moving at its fastest speed. Its potential energy is at a minimum because the swing is at its lowest point. The swing again gains potential energy as it moves upward. At the top of its arc, it once again has zero kinetic energy and maximum potential energy.
Greetings to all. Today, I, Vidita of Standard 9, is here to explain the law of conservation of energy and, of course, an activity for its verification. Now, the question that arises in our mind is that what is energy? Energy, according to the scientists, is the capacity of a body to do some work. It exists in many forms such as heat energy, wind energy, potential energy, kinetic energy, and so on. Its standard unit for measuring is joules. It can neither be created nor destroyed. Now, let us move to its verification. For example, a swing is at rest, which means that it contains potential energy. When we push it, it means we use our energy to push it. The energy gets transferred to the swing and it moves forward and backward. At the highest point of its arc, the kinetic energy becomes zero again, and when it swings again, while covering, it has kinetic energy, which proves that energy just gets transferred and not wasted. Thank you.
Good evening, everyone. I am Gayatri from class 9th B, and today I am here to give a seminar on the topic Law of Conservation of Energy. What is Law of Conservation of Energy? Well, it states that energy in an isolated system remains constant throughout. That is, energy in it can neither be created nor be destroyed. The only thing is that it can be transferred from one type of energy to the other. There are many types of energy. For example, potential energy, mechanical, solar, wind, nuclear, and many more. So today, we'll see an activity which will indeed help us to prove this law of energy.
Now, you can see this toy swing. When this toy swing reaches its maximum height, there its potential energy is maximum, whereas its kinetic energy at that time is zero. As the swing will come closer to the ground, its kinetic energy would gradually increase, whereas its potential energy would keep on getting decreased at a point where its height would be zero from the ground level. There, its kinetic energy will be the maximum, and the potential energy would therefore completely vanish. As you can see, that energy is getting transferred from one type to the other. Potential and kinetic in this case. Here, energy is neither being created nor being destroyed. This clearly proves the law of conservation of energy. Thank you.